So can one of you quickly summarize what we have discussed in our yesterday's session? Just a couple of lines.
So yesterday we discussed about key differences between abstract class and interface. So in abstract class, one of the main differences we have we have a abstract method, and it can have a regular method with that have no implementation.
Okay.
I mean, sorry, it can have abstract method or a method that has no implementation. And but in interface, they just have an abstract method.
Okay.
And we discussed more like some of the other key differences, like abstract class can only extend one class, but can implement multiple interfaces. We don't need to override method because abstract class cannot contain only contains unimplemented method. And in the interface, there are a couple of key points we discuss, such as an interface cannot extend only one class or abstract class, and interface can extend multiple interface and cannot implement multiple interface. And every interface method in a public every interface method in interface I mean every method in interface is public, and it cannot be private and protected. And same as like it cannot be final or static, since it's abstract method.
Okay.
And we talked about exception handling. An exception is an abnormal condition that arises in the code, and it is an object that describes an error or exception condition.
Okay. Yes, thank you for that, Vasha. See, just to add a couple of things, right? Your abstract class can also contain methods which are implemented also, right? It can contain both methods which are not implemented. The methods
Yes.
which doesn't have implementation, we call them as abstract methods, which have just declarations, right? And we just try to understand the differences between classes, abstract classes, and interfaces. So why do we need abstract class and interfaces? What are we going to achieve with abstract class and interfaces? I want others to answer. Yeah, Varsha. Yeah, I know you know the answer, but I would like to listen from others. What is the purpose of having abstract classes and interfaces? What are we going to get out of it? Anyone? Ashish, Roshan, Sheila, Suman. Anyone? Who's this?
So abstract can be subclass.
Okay. Not really. Like, who is this TS? Can you just join back with your proper name? Yeah. Anyone? Why do we need interfaces and abstract classes in Java? Yes, Suman, are you speaking?
Yeah, so for the abstract class, they can have a final static variable, but for the interface has only static variable.
No, my question is, why do we need abstract classes and interfaces? What is that something we are not able to achieve with classes? Why Java has abstract class and interfaces? I'm just asking a very basic question, right? Okay, Varsha, you can also answer. Anyone?
We support a multi-interface.
No.
Okay.
To reduce the complexity of the code.
Right, to reduce the complexity of the code. That means to follow the abstraction principle of object-oriented programming, right? To hide the complexity in any application, to manage the complexity, to expose only relevant details rather than exposing everything and mm, making people uncomfortable using that, right? Like suppose you are driving a car, right? If you just need to know pressing the pedal would the brake pedal would stop the vehicle. You need not know on pressing brake pedal an electric signal will go so to so and so, and it will stop the tires and blah blah. There's a lot of moving parts that are involved when you press a brake pedal, and a lot of things that is going to happen in that seconds time frame, milliseconds time frame, and eventually your car would come to a halt, right? You are not really I mean, how many people actually know what is the science behind that, or what is the mechanics behind, mm, pressing a brake pedal will cause any vehicle to stop, right? Like we're not really bothered about it, right? As long as you are into developing that thing, if you're just an user, you're not interested in it. The same applies here also, right? If you want to make use of some functionality in your application, you just need to know which one to call, which class or which method to call. You don't really need to understand the complexity or the implementation of it, right? That's why to manage the complexity, to make things simpler, that is, again, I'm repeating this, to follow the abstraction principle of object oriented programming, we have abstract classes and interfaces, right? So we talked about how inheritance plays role in terms of abstract classes and interfaces. And interfaces, if one key thing is both abstract and classes, they can have any type of variables, static, final, normal variables. But whereas in interfaces, it can contain only final and static variables, and all variables in interface are by default final. Okay, so it can have only final and static variables, it cannot have a regular variables, right? So that's what it is. And using abstract class and interfaces, you can restrict your subclasses to provide some implementation to certain things, right? So that's what it is. And we do understand that we cannot instantiate abstract classes and interfaces, right? Because they are unimplemented things, right? So you can't create them in the memory. You will be having some concrete class which would extend your abstract class, or which would implement your interface and provide the implementation for the unimplemented methods that are there in these two constructs, right? And for those are called concrete classes, and those classes we definitely can instantiate, right? Because which will have a complete details, it won't be having any unfinished methods. And then we spoke about exception handling, which is basically nothing but the abnormal condition in code, right? Which will basically make our applications execution stop immediately, right? And how we deal with this, right? And this is something we kind of started talking about today. So today we're going to get into bit detail into exception handling and all, right? And exception handling is a really important concept in Java. Okay, not just Java, any programming language, exception handling is the key thing. Because if you look at the example yesterday, right? This one, I added something called try catch here, Okay, if I take this out, for example, if I take this out, your hello is not printed at all. So your system will behave abnormally, right? But we shouldn't be having this kind of a behavior. Okay, we should be able to handle the exception and then address it accordingly, right? And if you see what is the exception here, you see some things got printed in the console, right? So it is called a stack trace. Okay, stack trace. So normally what happens is, in a stack, first main method is called, right? From main method you're executing. So the set of code flow and execution, the recursions, everything gets stored under stack, how the control of program flows, right? So whenever you get an error, it will print the entire stack trace on how, from which code line to which code line it jumped and where it caused the error and all. It will show clearly everything. If you see here it is showing, right? Com Java training under /jdemo in main method dot main, in main method /jdemo.java 13th line, it is causing an error. It clearly is showing this. Okay, this is called, sometimes you will definitely have a type of exception and you will have some meaningful exception, right? Here index 3 out of bounds for length 3, because index 3 is not applicable for length 3. For length 3, valid indexes are 0, 1, 2, right? So if you look at the exception here, what is the type of exception we got? What is the type of exception? Array index out of bounds exception. Okay, so that is something meaningful, right? Like a programmer can understand, okay, that means we are somewhere referring to incorrect index of our array, right? So it gives a proper description with a proper error statement and all, right? And in general when we talk about exceptions, right, they most of the times they will be generated at runtime, and we need to catch that exception, right, and then proceed our flow of execution, right? And this stack traces are really important in debugging what is the error, where is the problem and all, right? So if you have to fix this program, right, if you don't want to, if you don't want if you want to, you shouldn't get this error, how do you fix this? How do you fix this?
Use the exception and catch and try.
Catch and try is how you handle the exception, right? But in general, I don't want to get this exception at all. Okay, forget about handling.
Focus on your try to not make errors.
So don't think too much, right? First of all, this is incorrect. You shouldn't be writing code like this. Just remove this. Okay, as simple as that, right? But if at all, if at all there are some exceptions which you don't know what will happen at the runtime. Okay, see this, you clearly know, right? This is incorrect usage. Yes or no? Do we clearly know this?
Yeah.
We clearly know it, right? So no need to handle this. You just remove it. I give you another type of exception which we don't know data at runtime. I mean, which we don't know the data. Okay. For example, you have a string like this. Okay. And string str equal to, let's assume it's null. Okay. And here str in capital. Okay. Here I did str dot to uppercase. Okay. It is giving an error saying I should initialize the variable. Okay, I initialize it to null. So what will happen? Any guess? Any guess, guys? What will happen?
We'll get an error.
Why?
Because there's no string.
There is no string, right? When you say it's null, there is no string. That's right. But what error we will get? Let's see. I'm running the code. Again at line number 18. This is the line number 18, right? Line number 18. So if you see what is the error here, java.lang.null pointer exception. That means you're basically trying to call some method on a value which doesn't exist, which is basically null, right? So that's why you're getting here null pointer exception. Suppose this is some meaningful value like this AC like this, right? Then you're not getting exception. You will have the output, right? But let's assume in your program, you are expecting string from somewhere else, right? You don't know. What if you get some valid string, you would definitely do this. .2 you would do this. But some other application is basically sending you this value. So there can be some problem at their end and they might be sending null, right? So how do we deal with this? I'm giving you a different situation now. Okay. You guys understood the question, right? I mean, if you are getting that value, you have some control over it, right? You have clear understanding whether null is possible or not, but some other system is sending, it can send. And how do you handle this error here?
So if it's null, then we can try catch.
You want to do try and catch. Okay. Yeah, you will handle the error, but you will have 120 of such strings that you'll get. Will you put everything into try catch?
No.
Try catch is not a straightforward solution every time to handle some. And this is specific to null pointer exceptions I'm talking about. Okay. This is specific to null pointer exceptions. How do you handle this? Okay, I'm giving one more minute. Just think. This is a regular problem. I mean, generally new Java programmers, right? They end up writing code in such a way that end of the day, there will be too many null pointer exceptions.
Can we use if-else condition?
Okay.
To check if the variable is null or not?
If, tell me what to do it.
If a string is not equals to null,
If a string is equal to none.
Then equals or not equals. It should be not equals, right? If string is not equal to null, only then execute the statement. If string is equal to null,
Right.
what is the point of executing this statement? Nothing, right? So after putting that condition, if you run, yeah, there is no error, right? So this is expected here. See, if string is null, there is no point of executing this statement. So I will skip executing this code in first place. Okay. If you got my point, right? Rather than having an error,
Yes.
I'll just skip this. executing this. In a case where string is not equal to string is equal to null, I'll not execute this. In a case where string is not equal to null, only then I'll execute this, right? Now if my string is equal to AC, some valid value, then it prints, right? Then I want this code to be executed. Okay. So this is a one way of handling null pointer exceptions. I'm giving you specific very specific examples. Okay. So by this, you guys understand that try catch is not a solution every time. Okay. You put try catch when you want to monitor certain code that you expect will throw some runtime exception. You expect it, you anticipate it, you put it in try catch and you handle. When you get the error at runtime, then probably you can't do something about it, right? But things that are in your control, like this null pointer exceptions, right? You can definitely put these conditions. These are called null check. This is called null check condition. So see, like I was saying, right? I mean, many beginner programmers who start into Java, right? They end up writing too many null pointer exceptions because they might be expecting that value will come somewhere over of the top. They may be calling using making use of string or some variable or some object. They might be using it there. Okay, and they think that will be available and they'll write their code. They will think that it will not become null and all, but at runtimes there is a probability that it will come null also, right? Then it will result into null pointer exception. Okay, so we should be handling this the null pointer exceptions by putting these kind of conditional checks. Okay, so in yesterday we already saw, right? Like if at all you want to handle exceptions like this, right? If you expect some code that will basically cause error, you would surround it in a try catch block like this, right? Like if you see, this is a try block. Inside this try, you can put any number of statements. Like you can put 1, 2, 3, 20,000 lines of code also. How many lines of code you want to basically monitor, or you suspect that there might be some exception, right? And you will catch that exception. Okay. It will be of type exception, and you can put sysout, and you have e dot print stack trace method or e dot get message method, which will basically print some related meaningful information of that. Okay, like related meaningful information of that error. Okay, so this is a one way of handling things. Okay, that is whatever you want to monitor, you can put it in try catch block. But in general, Java's try catch block syntax would look like this. Okay, so let me just give you an example.
So I have a question.
Yeah.
So when you assign to that string variable AC, what if we just leave the double quote? What does it mean? I have seen somewhere, but I'm not.
It's a blank. Again, that is also a problem. Okay, that's a blank. It's a blank. That means it's an empty string. Empty string is different and null is different. You're getting it right? Like say for example, let me comment this. It's an empty string. What do you think it will happen here? There is no error because it's an empty string. Okay, empty string. It will be considered as, but it's not a null string. Okay, understood, right? So that's why in case of empty also, doing this operation doesn't make any sense. So that's why wherever people put null conditions, they'll basically check for both. Okay, they will do this also.
So for the
They'll do both these things and then they will execute. Okay. So it's like whenever you're working with strings, you should always check for null and they are empty or not. You should check for both and then apply your operations. Okay. Yeah, you're saying something.
So we are using so we use a try-catch block on just for the single request, right? And if then condition for a multiple request, is that?
No, there is no such thing. I just gave you that if condition example only in case of null pointer exceptions. There are hundreds of types of exceptions in Java. Okay, for everything, if is not solution. I gave you if. See, wherever we can resolve that exception with some condition programming based checks, you will use that programming checks like this, if and all. But wherever you can't do it, you really don't have any clue, or some other code is telling you that I'll throw you some exception, there you will put try catch. Okay, don't think if is not a solution for handling exceptions. I just gave you an example of there are different types of exceptions. See, in case of array bounds of exception, what is the point of putting if condition there? There is no point, right?
Yes.
That's my point. So it's only just in specific case of null pointer exception I told you to use if, but in general, every exception handling, you whatever code you want to monitor for some exceptions, you should always put it in try catch. Okay, so there can be different exceptions thrown here. Okay, this can be exception type 1, exception type 2, like this type 2. I'll tell you what are these exception types, and this is the syntax that I'm showing. And finally, you have this finally block. Okay, F-I-N, this is N, finally block. Okay, so this is the general syntax of your try catch block, right? So like I said, all the code that you want to monitor, you should put it in the try block. Okay, and after that you have a catch, and finally, okay, you can have multiple catch blocks, because that, like I said, right, there are different types of exceptions are in Java. Like you don't know that particular piece of code which you are trying to monitor and try block, it can throw different types of exceptions, right? So you can put different types of exceptions here. So for every type of exception, you can do a specific kind of handling behavior there. Okay, so that's the reason you have multiple catch statements like this, right? So in general, let's this exception is a object, right? It's an inbuilt Java class, which is, if I click on exception, if you see, it's an inbuilt Java class, right? Class, public class exception. This is an inbuilt class of Java. So let's try to understand the exception types that we have and subclasses and all the built-in things that we have within Java. Okay, so if you talk about the exception inbuilt classes, at the top you have a built-in class called throwable. Okay, throwable, that is a B. Okay, so it's a throwable class is there. So if you're seeing here, this exception class is extending what? Throwable. Okay, throwable. That means throwable is a parent class and exception is a child class, right? And then you have exception. So this is the hierarchy. Okay. Throwable is the parent class, exception is the child class. Okay, and then you have another class also, that is error class. So throwable is the parent class and it has two subclasses, exception class and error class. And under exception, you have another class called runtime exception. Okay, So this is the general hierarchy of the exception. So we will be talking this more, right? And if you see here, if you see, for example, this error, right? Uh, this error is something, you know, it is not supposed to be caught by our programming. Okay, error is error. It's like it is basically problem with your runtime environment. Okay, runtime environment in the sense, suppose like for example, uh, like you have a stack overflow error. Okay, stack overflow in the sense, for example, you gave stack memory certain area, certain space, and it is filled up. Okay, is it a problem of our programming? No, right? It's a underlying resource related error, right? Are you guys understanding me? Suppose your Java itself has heap memory, right? And your heap memory is full, completely full, and your Java JVM is not able to allocate any more new objects, and it will stop the program execution there. Okay, is it an exception?
No.
Error.
It's another situation, because errors are something that's caused by external factors, not because of our programming. Okay, if some abnormal condition that happens which will halt our application because of our programming, we are classify them as exceptions. But if it is something that is that's the external sources are contributing to this, it is called an error. Okay, so because you cannot do anything, if anything programmatically, if your memory is full, you can't do anything, right? You just need the resources to do something in first place. Okay, so these kind of things, they fall into error. Okay, like I said, just keep these two things in mind, like out of memory error, stack overflow error. These are some examples of error. Okay, so out of memory, you know, right? Like we discussed, when we are talking about heap memory and stack memory in Java, we did in fact talked about these two things. Okay, so now I'll just put, I'm just telling there are different types of exceptions, right? Like let's look at one, what are the exceptions you saw till now? What are the exceptions you saw till now?
Time arithmetic. SQL exception. Null string null exception. Class not found exception. Or yeah,
Okay. No, we haven't discussed those many exceptions. What are the exceptions I discussed? Let me put it this.
so just a string null time exception, and then
Sorry.
Null pointer exception.
Pointer exception, and what is the other exception that we discussed?
runtime right now.
Try
What
catch.
is the other exception we discussed? Array index out of bounds exception we just saw, right?
Yeah.
Did we saw array index out of bounds exception or not here? Over here? We saw, right? So here I'm printing message, but instead, suppose let's say I do here t dot print stack trace. If I do this, what is the exception I'm getting here? Array index out of bounds. This exception is present in java.lang. Like Java by default created this exception class for you. Okay, understood, right? So this is a array index out of bounds exception. Suppose now I'm trying to write some code here. Okay. I will say int this one, 0. Okay. Here result is t by d. Okay. What will happen here?
Array.
If you see, this is clearly an exception. Okay, I'll just comment this. Here, do you see some exception that will happen here?
Will give us a 0.
Hmm?
The result will be 0.
Result will
So
be
Arithmetic.
divided.
yeah, someone is saying something. Yeah, I think who is it? Ashish or yeah, someone is saying something, right? Come on, guys, have a look. Make it quick. If you see here, C value is 10, D is 0. I'm doing C by D. What will happen?
It's going to be infinity.
Mm,
Arithmetic expression.
arithmetic?
Array.
Someone already said the answer. It will throw an arithmetic exception. Who is this? Someone, is it? You already know, you are already aware of it, or you're just guessing it. See, normally in mathematics, when you divide a number by 0, it is not infinity, it is undefined. Okay, division by 0 is undefined by rule. So that means no, it's not preferable. Okay, it's undeterministic in nature. So in that case, this should throw an exception at runtime, right? Your CPU will try to do the division on these numbers and it will find that we are dividing by 0 and eventually lead into the undefined situation. So then it is again abnormal thing that is happening, right? So what is the type of exception that we get here? Arithmetic exception, which says division by 0. Okay, so now I can actually write a multiple catch statements. I can write one more catch like this. Okay, and here I'll say let me just use a second one, and here I'll make use of this arithmetic exception. I mean, it is clearly showing, right? If you see here, division by 0 at line number 17. This is the line number 17, right? So because of this, you are getting that exception. Okay, now I can write arithmetic exception like this, and even here also I'll do e dot print stack trace, for example. Or probably here I will say I want to throw some meaningful exception saying division by 0 is not allowed and undefined in nature. Okay, some message I'm throwing. Okay, but this is giving me compilation errors. Why do you guys think so? Any guesses again? I'll just highlight the error. Okay, it says syntax error. So let me just put this curly braces. But even then it is showing exception. What is that exception? Just read that exception. It is giving some compilation error. It is not able to compile successfully. What is the, can you guys someone read that compile time error quickly? Can someone read it?
It says unreasonable catch block for arithmetic exception. It is already handled by the catch block for exception.
Okay, what is this? What exactly you guys understood by this? It is basically saying, I have written multiple catch hierarchy here, right? It says it is not able to reach here because this sort of exception is already handled at exception here. Okay, that is what it is saying. Okay, if you see here again, read the error. Unreachable catch block for arithmetic exception, it is already handled by catch block for exception. It is because if you see in the hierarchy, okay, exception is the parent class. Okay, under runtime exception, you will have the here you will have arithmetic exception, null pointer exception, array index out of bounds exception. All these are arithmetic exception. Next. Array index out of bounds. All these are subclasses of runtime exception, which is in turn subclass of exception. So that means you are using superclass first, so it will not reach here. So to make this work properly, you just need to interchange this. Okay. So I'll just take this arithmetic exception like this, and just put exception here. So when you do this, now it will not throw any error. Okay. Now if you see, I execute this, division by 0 is not allowed and undefined in nature. You are getting this message, right? Because you are dividing by 0. Let's assume this is happening. What will happen now? Empty, right? Because this exception index by 0 is handled here. So if you want, you can just say this out. You can say any other exception other than arithmetic is caught here. Okay. Now you're assigning array index out of bounds exception here. Like when you see here, now this catch got printed. So that means if it is specific exception, it would be cached by this catch block. If it is any other exception other than the above general exceptions, everything is handled here. Okay. So when you define multi-catch statements like this, right, you really need to be aware of the entire hierarchy. Okay. So you can also put another catch here. Okay. Control Z, and you can put another catch here, and here you can say array index out of bounds exception. You can say invalid array index is used. Right. Here you can say uncaught. Right. So when you use this, you are getting this exception. Invalid array index is used. This one, right? Because of this array index. If you put both here, first, now what will happen? Tell me. Now you get a possibility of both arithmetic and array index out of bounds exception. What will happen here? What will be the output of this program?
First and second.
No, I didn't understand. What is first and second?
The first catch and the second catch, the arithmetic and the array index.
first catch, arithmetic and array index. You will get both the exceptions, is it? Okay. Any other answers?
I think all three.
Sorry, what it is? What is the output? Sorry, I couldn't understand you. Could you please repeat it again? Okay, I'm just executing this. What is the output? Array index is unused. So basically, array index out of bounds exception is executed first. Obviously, right? Or of these two lines, the first line that will be executed is this one. So obviously, it will throw array index out of bounds. It will not execute anything present in try. Okay, just remember that. Okay. Say for example, if I put sys out, here I'm writing I am in try block. Okay. Now I'm commenting this. Now you will get division by 0 exception, but this I am in try will not be printed because the moment exception happens, it will immediately skip the execution to catch block. So this is a very important point. Suppose in try block, you are writing 100 lines of code and in the second line exception happened, then the code from the third line to 10th line will not be executed at all. Okay, remember this very clearly. Understood, right? Understood, right, guys? Any confusion here? This is I am try is not executed because there is an exception here. If there is no exception, let's assume there is no exception at all, then it would definitely execute this I am try. Okay, it's printing here.
So
But the moment if
can
there
you
is, yeah,
can you put that second condition to another catch to print?
second condition into another catch. What exactly?
Yeah,
you mean
to
by this?
just to execute. If suppose I want to get both results, so how I'm gonna do it?
Why? See, one exception is enough, right? Like you are expecting either or will happen. In case when both happens, whatever happens first is first. That's all. There is no big discussion there. End of the day, exception is exception. It doesn't matter it is arithmetic exception or array index exception or anything, right? You might have written code this way to, so you are guessing that it either or thing will happen, both may not happen. You may think that, but in a scenario where both will happen, whatever happens first will be there. This is not a problem, right? This is fine. You got my point, right?
Okay.
Any exception is a problem for you. So see, the moment exception happens, it will be caught and it will be moved out of the try catch block and it will execute rest of the lines if you handled it. If you don't handle it, your program execution will stop then and there, right? So then how do you are bothered? Like if there is an exception at the line number 15th, how are you bothered about what is happening after line number 15th and all? You're not really bothered about it, right? All this will not be executed. Okay, whatever I'm highlighting here. At line number 15, you had an exception. So line number 17, 18 will not be executed at all. The moment you had an exception, your catch block will handle that exception. If at all you are handling it, if not, your program, if you don't handle it, your program will stop execution at line number 15. It will not go till line number 30 also. You are handling the exception. That's why after handling it, it is going and printing line number 30. Okay, but that doesn't mean whatever in whatever code you written inside the try this code, right? After exception, the following code will not get executed. Just remember that. Okay. And in Java, like we have many types of exceptions. Like for example, uh, in the slide there is one hierarchy also. Okay, if you see here, I I told you, right, this throwable is the parent class, and then you have exception and other. So the same throwable, error, and exception. And if you see, throwable is the throwable has a parent class called object class. This you know, right? Obviously we know object class is parent of every class in Java, so no need to explicitly tell you guys again, right? And if you see the throwable here, you have error and exception, and under exception you have runtime exception and IO exception, and under runtime exception you are seeing null point exception, number format exception, and all. And under error you have virtual machine errors, stack overflow error, memory errors. All these come under errors because of the external factors, not because of our programming. Okay, the things that happen are because of programming are will fall under exception, and you have runtime exceptions, IO exceptions, different classes like this. Okay, so IO exception is called a compile time exception, and your this one runtime exception is called a runtime exception. So in Java you have two types of exceptions: compile time exceptions and runtime exceptions. Compile time exceptions are also called as checked exceptions, checked. Okay, and runtime exceptions are called unchecked exceptions. This is the one: checked exceptions and unchecked exceptions. Runtime exceptions are called unchecked exceptions. Compile time exceptions are called checked exceptions. Okay, so I'll just give you an example of both in detail as we move further. And in general, so far we have used these keywords, right? We used a try keyword, catch keyword, and then and you can use this finally in the end. Okay, I'll write here finally. Okay, so I can write finally in the end here. So I will get executed always. So that means here you are getting the array index out of bounds exception, right? If you see, whatever you write in finally will get executed always. Okay, so that means for example, you might be doing some operations here. Okay, and you want to you got an exception, so your catch block will handle it and do something related to that, like it will probably print some meaningful error message and all. But in the end, your finally block will also get executed, and in finally what we actually do is we will do some cleanup operations. Cleanup operations in the sense, like for example, let's take one example, right? For example, you are basically calling some, or you are interacting with the database. Okay, in the try block you written a code where you are trying to interact with the database, right? And suddenly something happened in your application and some exception came, right? And you are handling that exception and you are moving on. But the problem is you will not be closing that database connection. Okay, because of that eventually you will end up creating too many connections, and your application will again stop because of increased number of DB connections. Or the moment you create more DB connections, your DB will automatically become slow and it will not respond. So basically, when you are making a database connection and interacting with the database to get some data or to create some data at the database end, once you're done with operations, you should be closing those connections. Okay, but suppose you are writing a code here to write close DB connection after doing all operations, right? We know that if prior to this line, if somewhere exception happens, then this close code won't be executed, right? So to handle these kind of scenarios, we kind of do this is a cleanup operation, closing database connection. So we will do, if you are writing 1,000 lines of code inside try and there are some cleanup things to do, right? Then you write those cleanup steps here. Okay, because finally block will be executed always. In your try catch finally construct, your finally block will get executed always, and we will do some cleanup things there. Okay, and understood, right? Like it will be definitely executed after your try catch block, right? And I mean, it will execute, finally block will execute whether exception will happen or it won't happen. Irrespective of that, finally block will execute. For example, if I'm just commenting the both here, okay, in this scenario there is no exception, right? But still my finally block will get executed. Okay, I will get executed always. So we normally use finally for, like I said, some cleanup operations. Remember this, like for example, closing database connections is one example. Okay, so just that, I think we'll stop here. So these are the different keywords that we use when we implement exception handling in Java. We used a try, catch, finally. Okay, we don't know what throw and throws are for, which we will discuss in our next session. Okay, so we'll stop here. Guys, I want to take some extra classes over the weekend to, like just 2 hours, 2 to 3 hours probably, to finish Java. So I want your availability on Saturday, Sunday time. So what time will work out for you guys? Varsha, Asha, Ashish, Suman, all. Or are you guys not available? What is it? I'll just stop the recording and then we'll discuss. Okay.